I only remember because I asked you to remind me. If I didn't ask someone to remind me, I would forget. Okay, so this I want you to follow without taking notes. I'm going to send this to you as soon as class is over. The key thing is this mess we're going to draw. So we've got here's our unit circle. And we are going to assume that everything that we're talking about is in quadrant 1. It would work for any quadrant, but the discussion is more complicated. So we're going to define a point P. Draw the triangle for P. So I know that, let's see, I think, let's see. Let me identify this using the right notation. Okay, they just want us to use. So the place where, if we drop a vertical from P, the place where we land is going to be called R. The origin is O. We know that the point on the unit circle is 1, 0. We know that the distance between the origin and P is 1. And we're going to call, I guess we don't even need that. Okay, great. Now, let's let T be any point. We're just assuming that it lives in quadrant 1, but it could be anywhere. And it's going to be x1. So P was actually going to be R comma, but we don't even use that. So T is x1. And I know what this means. It means that we're going horizontally by x and vertically by y to get to T. Also, I can extend the hypotenuse of this little triangle so that it reaches T. And I want to call this distance R, which means really I'm thinking of a big circle with a hypotenuse, pardon me, with a radius of R. So we know all 3 sides of this big triangle. We know that it is y up, x over, and that the hypotenuse is R. And what we also can see is that since the angle is the same in both triangles, these are similar triangles because we've got the same base angle. They're both right triangles. That means that the other angle is also going to have to be the same. So that means that I'm going to use these letters. 0, R, P, and 0, X, T, oh, no, wait. Y are similar triangles. And that means that their sides have to be proportional. So we could say 0r divided by 0p has to be equal to 0. Well, let's see, 0x is just x, 0p, that'll be r. So we have to have this relationship. Now, 0r lives in the unit circle. It's the x-coordinate of p, but the x-coordinate in a unit circle always goes with what?
Cosine.
Cosine, good. And what is the distance between the origin and P?
1.
And cosine theta divided by 1?
This is just cosine theta.
Cosine.
So now we have extended the definition for cosine to relate to the x value of a point not on the unit circle divided by the distance or the radius of that point from the origin. And that, let's see if I have a pretty copy, probably not. Por favor. Yeah. No, I don't think I did. Okay, so now we have, oh, I forgot to put my headphones on. Oh, how horrible. Yes. Can y'all hear me?
Yes.
Yes,
Okay,
ma'am.
groovy. So now we can look at this entire table. We have all of the trig functions by the sides of a rectangle, all of the trig functions by points on a unit circle, and all of the trig functions by a point anywhere. The cosine is x over r. The sine is y over r, which we could have shown very easily, but I don't want to take the time. Tangent is still y over x, and cosecant, secant, and cotangent are reciprocals of their friends. So y over r over y, x over r over x, and y over x over y. Yes.
You just have 10 minutes left, just to let you know.
Oh, thank you. Thank you. Thank you. So I wanted to spend the last bit of time that we have using this new definition
this extended definition of the trig functions, where we're no longer putting our point on the unit circle. So the step, we want to find which quadrant P is in, sketch the angle theta, and the reference angle, draw a triangle in the correct quadrant, label it, and find all the sides of the triangle, and then use the right triangle definitions. Okay, good. So let's let P be given as -12, -5. I want all the trig functions. For theta, if theta if pardon me, if T is on the terminal side of theta. So what quadrant are we in?
Quadrant 4.
Good. That means that theta starts at the positive x-axis and goes to the terminal side. The coordinates of T were 12, -5. And how can I label the sides of this triangle? What do the coordinates of a point have to do with the sides of the?
So if we look at the coordinate, 12 is equal to x and -5 is equal to y.
Good. And do you see that the negative is just indicating that the 5 is going down?
Yes.
I want you to start thinking about Pythagorean triples. What do 5 and 12 go with?
5, 12, 13.
Good. How do I know whether the 13 is positive or negative?
Because the hypotenuse will always be positive.
That's right. Very good. Oh, let's see. Have to go. Okay, good. No worries, Natalie, who's already gone. Okay, but she let me know. That was kind. And we want to label one other thing. Let's label theta prime. And why did I draw it there? Why did I put theta prime as that angle and not the upper angle?
The theta should be at point of origin.
That's right. Theta should start at the origin and go out. And why did we go up to the positive x-axis rather than over here to the negative x-axis?
Because you want the shortest distance.
Good. So theta prime is the reference angle which just means it's an acute angle that is related to theta. And now, can we write all of the trig functions of theta?
Yeah.
So let's see. Let's start with the two basics, sine theta and cosine theta. In terms of right triangle sides, let's write that down to get in the habit. Sine is
-5 over
Negative 5.
13.
okay, but let's write opposite over hypotenuse, and yes, it'll be -5 over 13. Cosine is
Adjacent over
Adjacent over
hypotenuse,
hypotenuse.
which would be 12 over 13.
and tangent.
Tangent would be opposite over adjacent. It's -5 over 12.
Good. Do I have, in order to find, let's start with secant. In order to find the secant, I know it's the reciprocal of cosine. Do I have to do 1 over 12 over 13 to find the reciprocal of 12 over 13?
Not necessarily.
That's right. I can just do what with 12 over 13 to find its reciprocal?
Just switch the numbers places.
Good. So 13 over 12 is secant. Cosecant will be
13 over -13 over 5.
and that's the reciprocal of sine. And then cotangent is the reciprocal of tan. And that'll be
-12 over 5.
awesome. I think that's good for today. Yikes, yes. But I wanted you to see the power of drawing a triangle. You identify the quadrant, you slap a triangle in there, draw theta, figure out what the theta prime is going to look like, and then use the right triangle definitions to figure out some of the sides. Use the Pythagorean theorem to find the missing side if you need to. But we know 3, 4, 5, 5, 12, 13, 7, what's the 7 one?
7, 24, 25.
And
8, 15, 17.
thanks. These 4 will put you really solidly in the game. Most of the questions that require triangles that Alex will ask you will be in this kind of one of these triangles. So plus or minus, it may move, but these 4 Pythagorean triples will really do you proud. I'm gonna stop recording. Y'all are free to go.